First note on mirrors and chirality.
I can even give you dead ends in a path. So a dead end would be a discrete discord. And a discrete discord is when you run into a place where your set of axioms says hard impasse. There's something wrong here. But with some additional set of data, you might be able to bridge that gap. So that would be a mathematical discord. That would be a discontinuity in your path, and you'd have to include some extra information. This could be like in dealing with polynomials, where you just can't factor it, and you grab the computer, you say, it doesn't have any different axioms. It doesn't do anything different. And I would say, yes, it does. It gives you a bridge between the discrete discord you had there and an exact answer. So, and then we have what are called mathematical entropy. This would be a dead end that is the death of an idea. It's not a wall that isn't a path, it's something you have to get over, or you can't find a shorter way around for some reason. You take the longer way and you're forced down it forever, but there was a shorter path back in time. Stuff like that would put you away from being on a path. So, when we have some axioms that bind things together, they bind them together by some set of rules. And those rules don't always fully define those things that those axioms create through these assumptions and these definitions they use from these basic ideas. You can call them assertions, you call them axioms in my head. Either way, it's difficult to try to figure out what you're dealing with in terms of algebra, but it's clear when you do it what you're dealing with. So, I need to express this notion of the entire space of paths, this place that's connected. In other words, if I can find some way somewhere, then I can somehow describe the entire space through this notion of these paths, this way to some place through some set of other places. At some point we make these huge leaps, and I ask you between those places, find me a path. And you would tell me that you've completely defined everything by paths. And I tell you, I can find you a shorter proof by computation. Would that computer ever try to turn this into a path? No, because paths explode axiomatically at that point very least.
Next note, chirality and mirrors.
When we're looking at chirality, we can instantly say things that will allow us to hopefully just do things easier, never have to deal with those structures again. Throw them into the mirror and say, look, they're all the same. That is something I'm having big trouble with. And the best analogy I have right now are magnets being broken and a mirror's flipping structures. Now, magnets can be broken very strangely. And I know that you can end up with circles that don't seem to express what you want, but express a region of almost like a certain amount of infinite chirality, and triangles that you can flip one way and flip another way, and then they stick and they have two dimensions of it.
Next note on constructive combinatorics axiomatization.
And for mathematics, I feel like this has to be the place you start when you're trying to deal with breaking commutativity. The order in which things are executed. Because if I give you some ordering and I say, this is not this, then I have assigned it some associativity to like the commutativity, right? That would be the chirality, associating some associativity to the commutativity. That's alien. Because I say that I have this like I have this combinatorial object. It's like all commutative. It just, all the objects can move around, they can move all over the place. And then I say, hey you're stuck right here. And then I say, you're stuck right here. And then I say, look, it's associatively starting to get somewhere. It's starting to have some restrictions. Commutativity, I'm so confused. I'm sorry. Because I don't know. Commutativity, the objects can do anything, like a quantum mechanical system with its matrix that can do anything. And somehow you are restricting the commutativities. You can't move. You can't move. Associativity says, you done first, you done second. You done second, you done first, move the brackets around. Yes. And it's through that process that I want to try to figure out what is this notion of chirality that I think we need to be looking at. And then I guess you get to full lockdown. I don't know what that is, but it's in quantum mechanics it would be a matrix that is completely dependent on the adjacent cells. They can't even move around in any ways. They can't bounce around in strange ways in a mirror that hates certain kinds of wavelengths. Because in mathematics we have this notion of an associative property. It means if I do it this, and then this, and then this, and I do it these two first, then it doesn't matter. And then on the same operation, we could have commutativity, which says I move it around and it doesn't matter. What if my brackets define the moving around operation? I know that sounds stupid, but my brackets could define a state of lockdown. And they would systematically lock down associativity in this case. It gets very, very ugly, I've seen, when I try to move brackets around here. But I think this notion of being able to do any set in any order and the commutativity of being able to move it around shouldn't be separate. It should be that objects inherently can move around in space. They aren't restricted. And their interactions upon some coming together of truth is not really caring about the angles. So when it comes out, all of it looks like the same thing, no matter which way you put it together. Or they all matter. It depends. And then there are objects that come together in ways that care about the order in which they came together. You came from this angle, or you came here first, and then that's what's important. That results in objects that are achiral. Okay, the mirror I have to define for my chirality is the coming together. They hit, and it's different. And it sees different versions through that mirror because of the angle it came in. So the mirror looks at this set of oncoming particles when they're coming together, the universe. It hits it, and suddenly they all look the same. So they're chiral. Yes, chiral by default. All things are the same. It's the interactions between the particles somehow. And so quantum mechanics would I guess, be looking at very chiral objects. These things come together and instantly it's blown into, guess what? All of them. And it says, I am completely associative across my matrix. Then it says weights and measures in future from given variables, but somehow it does ask that. It says instantly I am associative and I am all chiral. All interactions matter. And this is the place I start because this is the basic assumption about the way that things work if they are ordered. From previous numbers, I don't know what to say. So we start to break that somehow. And in combinatorics, we start out by being completely commutative. What is the notion of things having order? We are counting the order of things. We are counting the numbers of things. And if you want order, then I will have to establish order. I will have to establish a first, a second, a third, an ordering. You start to try to enumerate these and start to count them. The hope is that combinatorics starts out from a constructive almost start, and it is commutativity all the time. We can talk about the number of ways things can happen and we can begin to count them, and then in almost a dyslexic view of reality where we can't tell left from right, suddenly people start asking questions about the numbers for left and the numbers for right. And we start to have to deal with the problems of combinatorics and establish some kind of associative binding. And the hope in the end, I guess, would be that this binding would be tight enough to hold in numbers. We would say that after this point, adding any more associativity will go lower. I've overcounted or I've undercounted in some respect. Like I don't have orderings, now I add orderings. It doesn't matter, you're trying to if you're trying to prove it, it doesn't matter. It's annoying and this is embarrassing if people listen to this. There is some restriction you put on it that gives you a number that removes this commutativity that makes everything oneness. That is the assumption, that is the basis of quantum mechanics, that is the number that starts out with everything that is one and grows to numerous things that are brought down from there and up to the other spot. Combinatorics is this notion of, I give you a scramble. How many ways can I do it? Okay, restrict your scramble. What are you seeing? A beautiful balance in combinatorics that almost looks like a proof place.
The idea is we start out assuming every order is considered and then reduce these orderings to specific cases that restrict associativity and commutativity, thus constructively developing combinatorics.